Hello, folks. So this is part eight and of learning Rust from scratch, part eight, and we are actually looking at how our program works. This is kind of the usual stuff that software engineers do. They write a program, they think it won't work, and then it works. You just wonder how does it work, why does it work? And so in this case, how does this thing work wherein you create a guess initially, which is a string, and then later you create a guess, which is a unsigned 32-bit integer, 32-bit unsigned integer type, right? Um, so how does it work? So before that, I was also wondering, we didn't even mention what to parse it into. We just said trim it, and we get string, and then we say parse. Parse it into what? Is it parse the string into an integer, a float, a boolean. I was just wondering how that worked. For example, let me actually remove this and let's come this out. And then you can have this. What does it even say? Let's see what it says. Cargo run. It has a warning, but it runs, right? So now it says parse and it passes this into a unsigned use unsigned. So unsigned 30-bit integer, which is a positive integer because signed is negative. So um, I think how does signed work? Like, is it S32? No, it's not 32. It's just I32 or I think there's no signed, only signed. There's just unsigned or integer, that's all. An integer is both signed and unsigned. So now, if I actually convert this into a Boolean, what happens then? Please type a Boolean. Like I can just give this. Does this give a Boolean then? So here f is bool. Okay, so great. So into another type because parse is so general, yes. Because this is a general thing. I didn't say parse it into an integer or whatever. Nowhere I use an integer related thing. So usually, for example, in Golang, we say a to I, which is character to integer, or I to a, integer to character, and we use a library called conversion, conv is for conversion, right? So as we can read here, since because parse is so general, since it is so general, it can cause problems with type inference, right? Like as such, parse is one of the few times you will see the syntax affectionately known as the turbofish, which is colon colon and then this. So F. So this helps the inference algorithm understand specifically which type you're trying to parse into. So basically here it infers that if you don't give this, it doesn't understand what is the type then. Type annotations needed cannot satisfy from us from string colon colon error, right? So compiler full diagnostic. Type must be known at this point, right? We need to know the type at this point, so cannot satisfy. So when you go to says, oh, it goes to from string actually. Interestingly, it doesn't go to parse. Anyway, so I want to actually go here, and it will come to that. So parse can parse into any type that implements the from string trait. Okay. So we'll return error and basic examples, parse it into an unsigned 32-bit, parse it. Okay, so here we say colon colon and then we just say it's called turbofish apparently. Um, so we say colon colon and then we say the type here, so it's an unsigned 32-bit. And here also we say unsigned 32-bit and gives an error. So either this or I say this colon bool, and it's good to go. It says bool from here, right? And if you don't give it here, you instead mention it here, then it'll accordingly take a boolean, and I think it'll accordingly give you a, for example, if I say okay, it'll say pass bool error. So if I say true, this is true. If I say false, it's false. If I say true like this, it's still an error. So I think it just understands from here. So that's pretty cool. And the next thing, I'll probably start off a new video, or actually I can do it as part of this itself. There's just a little bit more. So how is guess coming up again twice, right? Like how can you declare two different variables named guess of different types, right? Even of same type you can't, right? Generally in a programming language. So what happens? Like in JavaScript you can, I think. What happens in Rust, especially in a statically typed language? It has a static type system, right? So we create a variable named guess. But wait, doesn't the program already have a variable named guess? It does, but helpfully, Rust allows us to shadow the previous value of guess with a new one. So we are shadowing it, right? So shadowing lets us reuse the guess variable name rather than forcing us to create two unique variables. For example, guess underscore string and guess. For example, so we'll cover this in more detail in chapter 3, but for now, know that this feature is often used when you want to convert a value from one type to another type. So we bind this new variable to the expression guess.trim.parse. The guess is in the expression refers to the original guess variable that contained the input as string. The trim or method on a string instance will eliminate any white space characters at the beginning and the end, which we must do before we can convert the string into an unsigned 32-bit integer, which can only contain numerical data. The user must press enter to satisfy a read line and input their guess. Um, so which adds a new line character to the string. For example, if the user types 5 and presses enter, guess looks like 5 new line. The new line represents new line. On Windows, pressing enter gives, and I think this carries written or something in the new line. The trim method eliminates new line slash r slash n and everything, resulting in just 5. The parse method in strings convert a string into another type. Here we use it to convert from a string to a number. We need to tell Rust the exact number type we want by using let guess unsigned 32-bit. The colon after guess tells Rust we will annotate the variable type. Rust has a few built-in number types. Unsigned 32-bit is an unsigned 32-bit integer. It's a good default choice for a small positive number. You'll learn more about other number types in chapter 3. Additionally, the unsigned 32-bit annotation in this example program and the comparison with secret number means Rust will infer that secret number should be an unsigned 32-bit as well. So now the comparison will be between two values of the same type, right? So as you can see here, secret number, where is it? So your guess, secret number is here. It's a integer 32-bit, but once I actually compare this, here it says integer 32-bit. Once I do this, it'll become unsigned 32-bit. So additionally, in this program will infer that secret number should be unsigned 32-bit as well. So now the comparison will be between two values of the same type, right? So now we see the change as unsigned 32-bit, right? So instead of just integer 32-bit. So the pass method will only work on characters that can logically be converted into numbers, so can easily cause errors. If, for example, the string contained thumbs up, there would be no way to convert that to a number because it might fail. The pass method returns a result type, much as the readline method, whereas discussed earlier in handling potential failure with result. Um, so I think this was here. Let's go back. We'll treat this result the same way by using the expect method again. So if parse returns an error result variant because it couldn't create a number from the string, the expect call will crash the game and print the message as we give it. So if pass can successfully convert the string to a number, it will return the OK variant of result, and expect will return the number that we want from the OK value. Let's run the program now. Nice, even though spaces were added before the guess, the program still figured out that the user guessed number 76. Run the program a few times to verify the different behavior with different kinds of input. Guess a number correctly, guess a number that is too high, and guess a number that is too low. I think we did these, and we have most of the game working now, but the user can make only one guess. That's right. Let's change that by adding a loop. So I'm going to stop here now, and then I'm actually going to continue in the next part, part 9. Let's see how that goes on, and I'll see you in the next one. Bye.